Stop scrolling right now, because in the next few minutes, we're going to shrink the entire cosmos down to facts that will fundamentally rewire how you see Earth's pale, silent neighbor. Forget what you learned in school. The actual journey to the moon is a breathtaking ballet of physics that almost ended in disaster countless times. Consider this: the sheer velocity required to escape Earth's gravity is so intense that you are essentially thrown into the void by a controlled explosion. Once you leave our atmosphere, the silence isn't peaceful. It's an absolute suffocating vacuum where a single puncture means instant catastrophe. The Earth, this giant blue marble you've always taken for granted, shrinks so fast that astronauts often describe a profound, immediate sense of loss. For days, you are sailing through nothingness, guided by calculations so precise they feel more like magic than mathematics. Did you know that during the Apollo era, the navigation computer had less processing power than your modern digital wristwatch? That tiny speck of rock ahead, the moon, is not just a destination. It's a world locked in a slow, perpetual gravitational dance with us. Even traveling at thousands of miles per h-hour, it still took 3 agonizing days just to reach the moon's gravitational influence. When you finally arrive, the landscape is not bright and inviting. It is a harsh, monochrome world, bathed in unfiltered, unforgiving sunlight. The famous dust, the regolith, is actually incredibly sharp, like microscopic shards of glass, created by billions of years of cosmic bombardment. This means that every step taken on the surface contaminates the spacecraft, forcing astronauts to become meticulous cleaners against this abrasive grit. And speaking of dust, without an atmosphere to hold it down, it clings to everything via static electricity, turning pristine surfaces into fuzzy gray messes. Stepping onto that surface, you weigh only 1/6 of what you do here, making you feel simultaneously clumsy and utterly superhuman. That low gravity means a simple jump can send you several meters into the air, demanding complete relearning of basic human movement. When you look up from the moon, Earth doesn't just hang there. It glows with an intensity that has no parallel in the barren lunar sky. Because there is no air to scatter light, the stars on the moon don't twinkle. They are sharp, unwavering pinpricks of pure energy. The temperature swings are lethal, baking one side at over 250 degrees Fahrenheit, while the shaded side plummets to nearly -300. To survive this, the spacesuits aren't just clothing. They are miniature, pressurized spacecraft, meticulously regulating every single aspect of life support. And the return trip involves reigniting the ascent engine with pinpoint timing, hoping the lunar surface doesn't just shake apart beneath you. The final re-entry into Earth's atmosphere is a searing, orange, hot dive, where the capsule briefly becomes a temporary, controlled meteor. That friction generates temperatures hotter than lava, relying solely on the heat shield to prevent the crew from incinerating microseconds from home. The sound of parachutes finally deploying is often cited by astronauts as the most beautiful noise ever heard by human ears. But the moon's story isn't over. Scientists are now looking at mining its frozen polar water, turning a dead rock into a cosmic gas station. This water, when split, provides breathable air and the rocket fuel needed to reach Mars and beyond, making the moon our essential first stepping stone. Imagine a permanent base where you can look up and see all 7 continents simultaneously. A true testament to human ambition. Every crater, every dark mare, holds a geological record stretching back 4 billion years. A diary written in rock dust that we are only just learning to read. We've only scratched the surface, literally, sending just a handful of people to that silent world over 50 years ago. The challenges of radiation, equipment failure, and sheer distance are humbling reminders that space does not forgive even the smallest mistake. But the next generation of explorers, armed with better data and bolder goals, will return to the moon and then push further into the solar system. The sheer complexity of navigating the Sunday's constant particle assault is a factor that dominates every deep space mission planning session. This journey, this round trip, is perhaps humanity's greatest proof that we can solve problems that seem impossibly vast when viewed from our cozy blue home. If this deep dive into the physics and drama of leaving and returning to Earth has sparked even a flicker of curiosity, you know what to do next. Hit that subscribe button to join us on the next cosmic adventure, and drop a comment below telling us which microfact absolutely blew your mind the most.